Good morning, ladies and gentlemen. Today we are going to start a new topic. Our topic today is a very interesting topic. I'm sure some of you have heard about it from somewhere, from your peers, from your friends, from your older brothers and sisters. It's a pretty interesting topic. It's not difficult. It just needs your attention. Uh, but first, this chapter that we are about to start today requires your basic knowledge of the information from previous classes. So there are things from grade 9, grade 8 that you learned that you are going to need uh, in order to understand this topic that we are about to begin. So first of all, I'm going to ask you guys a question. First, let me draw for you guys a triangle. So if I may ask, what do you call this triangle? Yes, Tabiso, that is correct. This is a right angled triangle. That is correct. Let me draw another right angle triangle for you guys. This is our right angle triangle, and let us name this angle as theta. So we know that uh, in the other chapter, the algebra, the most used variables were x, y, z, and other alphabets sometimes. However, in this chapter, we are going to use uh, other variables such as theta. This is theta. Others may look like this. This is beta, and this is alpha. So these variables are going to be used for the unknown uh, angles. Like in this case, we can see that we don't know the angle, so we have put theta instead of x or y. But you can put y as well. But we'll get into that as we continue with our lesson. So let us first name the known side, which is the side opposite the 90 degrees angle. What is the you guys already named this side as the hypotenuse side. Going to write HYP for hypotenuse side. So we are going to name the other sides according to their relationship with the angle that we have been given. In this case, we have been given theta is our angle of interest. So we are going to let me name these angles. Let me name the whole triangle. This is triangle A, B, C, so that it is easier for us to find these sides according to their relationships with the angle of interest, which is theta in this case. So, if I may ask you guys, what is the relationship between side AB, which is this one, and theta? Anyone? Mzizi, yes. Mzizi is saying AB is opposite theta. Can you all see that? Very good. So we can say that AB is opposite. So we are going to name it and call it the opposite side of our angle of interest, which is theta. How about BC? What is the relationship between theta and BC? Yes, cellular. It is next to. I like that answer, cellular. Cellular says side BC is next to theta. So in mathematics, in this case, we call that side adjacent. So side BC, we can say that side BC is adjacent. It's adjacent to our angle of interest theta. So let us write this here. AB is opposite it is opposite theta. That is the relationship between theta and side AB. And it has been established that side BC is, come along all of you guys, is adjacent. It is adjacent to theta. Do you guys understand? Do you see what I'm saying? You understand? Okay, I'm going to make another example for you guys. Let's just make another example so those of you who don't understand clearly see what we are talking about. Excuse me, I had minor problems. Somebody came in, but we may continue with our lesson now. So let me draw another rectangular triangle. We are going to name this triangle as PQR. We are going to name this side as beta. So we are going to name sides. Let us first name the side that is opposite 90 degrees. That side is called the hypotenuse. This is the hypotenuse side. We all know this. We all understand this one, right? Very good, guys. So what is the relationship of side QR in relation to, let me change the color for you guys, side QR in relationship to angle beta? So we can see that this side is opposite our angle of interest beta. So we can say that QR is opposite beta. So this is the opposite side. The opposite side of beta. How about PR? Correct. You guys are correct. PR is adjacent because it is next to. It is the adjacent side of it is the adjacent side. So let us for the sake of making others understand, I can see that most of you understand already, but I'm going to make a last example. I'm going to name this angle as alpha. This is alpha. What is alpha's relationship? What is PR in relation? Actually, let me ask this like this. What is PR in relation to angle alpha. Yes. Senzi. Yes, Senzi. Senzi is saying PR is opposite. Uh, alpha. So PR is the opposite side of alpha. How about QR? Yes, MCZ. MCZ is saying QR is adjacent because it is next to. It is adjacent. So we can see that all of our sides now have been named, and all of our sides are named according to the relationship with the angle of interest. As you saw here that beta, in beta, QR was opposite beta. However, the same QR is adjacent now. It is adjacent to angle alpha and vice versa. We can see that side PR was opposite alpha, but the same side PR is adjacent to beta. It's adjacent to beta. So the main thing, the takeaway message here is that we must focus on interest first for us to define its relationship with the given size. You all understand? You all understand? Very good. So let us move on now. So, as I have already said that in this chapter you guys are going to need basic knowledge from the previous grades. So the first one was Pythagoras theorem, and I've already seen that most of you still remember it. You know how to work your way around it, which is a very good thing. The second important uh, topic from the previous grades that we are going to need in order to understand this topic is similarity, the concept of similarity. You guys remember similarities, where triangles that are similar, it means that their sides are in proportion, meaning that these sides increase or decrease in the same ratios. So right here I have made a really quick task for you guys to do in order to freshen your minds up about this, about similarities. What you need to do is to provide the answers for these ratios. It's AB, number one, it's AB over AC, which is AB is 3 over AC over BC. I mean AC, which is 27, it's going to be 3 over 27, which I think is 1.9. 1 over 9. So you guys provide the rest for me. I'm going to, I need you to use your calculators and tell me the answers. So, Mrs. please give me the first answer. Mrs. says the first answer is 1.9. What about the second answer? The second answer is 1.3. What about the third answer? The third answer is also 1.3. Moving on to triangle PQR. Yes, it's 1 over 9. What about PR over QR? It's 1 over 3. This is 3. What about PQ over PR? This is also 1 over 3. So if you look at this closely, you can see that this one, this side, and this side are actually similar. They are in proportion because they are both 1 over 3. Same goes with this side and this side. So you can see that triangle PQR is actually a bigger triangle of ABC. It's a reflection, the same triangle ABC, but it is just bigger. But you can see that it increases with the same ratio, the same size. So I hope you guys remember that. I hope you remember these concepts from the previous grades. Do you remember now? That is very good. So now we are moving on. We are going to make an investigation now. So right So now we are going to do an investigation. I will need you guys, each and every one of you, to draw a right angle triangle. The right angle triangle should have angles, uh, two angles, 30 degrees and 60 degrees. However, the size of the triangle is not very important, but it is important that you draw an accurate diagram because you will need the measurements, and they will be worthwhile in the end. They will be the main basis of what we want to prove in this investigation that we are doing. So you measure only three sides of your. You draw the right angle triangle. It should have angles 60 and 30 degrees. You measure all three sides, and then you use these ratios that I have provided on the board to calculate using the lengths that you have measured using your ruler. I will give you some time, 5 minutes, for you guys to do this. At the end, after you have measured and calculated the ratios, you guys should compare your ratios with the person sitting next to you. These ratios should actually be the same. If not, it will mean that one of you guys actually drew the diagram that they drew was inaccurate. So let us begin with this investigation. All of you start writing. I'm going to give you 5 to 8 minutes to get this done. So here is mine. I'm going to draw mine here. I'm going to draw my own right angle triangle. It should have 30 degrees and 60, right? Can any of you guys, who of you has measured this sides? Oh, yeah. Can you give me this length? Oh, it was 4.8. This one was 8, and this one was 10. Okay. I'm going to only write the answers of those ratios, as you guys have already done this in your exercise book. But however, I am going to focus on the most important sides, or focus on the basis of today's lesson. Actually, I'm going to use AB. I'm going to first define the ratio of AB over AC, which is 4.8 over 10. This one is 4.8 over 10, and it's going to be BC over AC, which is 8 over 10, and uh, AB is 4.8 over 8, which is BC. So this is 0 point. Can you guys give me the answer? Calculate, use the calculator to calculate this. This is 0.48. This is 0.8. This is 0.6. So first, let us go back to angle DD. This was AP over AC. This is BC over AC. And this is AP over BC. These are the ratios that I'm going to focus on. But can you guys focus on 30 degrees? Let us look at 30 at angle ACB, which is 30 degrees. Can you name these angles, these sides, side AB and BC in relation to angle 30? Yes, Celulego. Celulego says BC is adjacent. So BC is adjacent. Right here it's adjacent. And what about AB? Yes, AP is opposite. So let us change this. This is the hypotenuse side. We all know that this is the hypotenuse side, right? This is the hypotenuse side. So let us change these and use these trigonometric ratios, these sides, by naming them opposites, adjacent, and hypotenuse. So it's AP. AP is AP over AC in relation to the degrees. AP is opposite and AC is hypotenuse. Can you guys do that in your, you're doing that in your workbook, right? What about BC? Name BC for me. BC over AC is yes, level. BC over AC. BC over AC is going to be yes, level adjacent over hypotenuse. That is true. It's going to be adjacent over hypotenuse. What about AP over BC? We're going to change this. AP over BC is AB over BC is going to be opposite over adjacent. Now we need you guys to use your calculators. I am pretty sure most of you are using Casio calculators. Look at your calculator. Find sine, cos, and tan. I'm sure that you have seen these. Now, uh, as you can see, sine 30. There is 30 here. Press sine 30. What is sine 30? It's 0.5. It's 0.5. Which one among these answers is closest to 0.5? That is 0.48, which is opposite over hypotenuse, right? So we can conclude and say that sine is always equal to opposite over hypotenuse. Uh, can you continue and press cos theta? Cos 30. Cos 30 is 0.866. 0.866 is closest to which number in here? Between these three. It's closest to 0.8, right? Yeah. So we can say that cos theta is always adjacent over hypotenuse. Let us write this here. Cos is always equal to adjacent. I'm going to use A over hypotenuse. I'm going to use A. What about this one? What about tan? Oh yes, tan is 0.6. Yeah, it's 0.6, right? Here we have 0.6. So We now know that tan is always equal to opposite over adjacent. Let us write sine here too, so that we remember. Sine is O for opposite over hypotenuse. Do you understand? Do you all understand this? But this we can create a mnemonic for this in order to memorize this and never forget it. We can create a mnemonic. So we know that sine is equal to. We now know that sine is equal to opposite over adjacent, right? Opposite over hypotenuse. That's sine. Sine has its s. It is going s is equal to opposite. That's O over hypotenuse. That's h. SOH. Same thing goes with cos. C A for adjacent. A hypotenuse. H for hypotenuse. It's h. Same with tan. It's T for tan. It's O for opposite. It's A for adjacent. So if you want to remember this, you should memorize this. Sokatoa. Sokatoa. You will always know these are the trigonometric ratios that you will know. You need to know. You can use these to find any angle and any side if you are given enough information. So at the end, it's sine theta. You can use any variable: sine beta, sine theta, sine alpha. It's opposite over hypotenuse. Remember, it's theta. Theta, it is specific. You have to remember that you must focus on the given angle, focus on the angle of interest. And that is how you choose which side is the opposite, which side is the adjacent in relation to that specific angle. You guys understand? Do you think now you can go back and solve that triangle that we were doing in the first uh So we have in the investigation we have found out that sine theta is equal to opposite over hypotenuse cos equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. Among all these three trigonometric ratios, you can see that we have the angle, which is theta, can be theta, it can be beta, it can be alpha. We have two sides, which is opposite over adjacent here, opposite over hypotenuse here, adjacent over hypotenuse here. So it is quite clear that you need to focus on the triangle you are given. For instance, let's just check this one. Let's say you are given uh, 12 here, and you are given 5 here. You are required to find this side. So our triangle is triangle PQR. You have to find QR. So you can see that QR is adjacent because it is next to, it is adjacent to 12 degrees. The other side that you are given is PQ. PQ is 5, and PQ is opposite 12. So you know that you should use something that has, you should use a trigonometric ratio that has adjacent and opposite. So you know that here you have to choose, and which trigonometric ratio is that? The one that uses opposites and adjacent. It's tan, right? It's tan. So you know that in this case you have to use tan. So you will use tan theta, which in this case it's tan 12. We are given the angle 12 equal to opposite is 5, and our side is QR, the unknown side QR. So QR actually equal to 5 over tan 12. This is going to be 5 over tan 12. This is going to give us, and this is going to be equal to, and you guys give me the answer. It's 7.8. You all can see, right? So I'm going to make one last example here because time is not on our side. I'm going to make one last example which deals with an unknown angle. In this case, you are told to find theta. What will you do? You will look at the relationship of theta with the given side. You know that this side, the side opposite 90 degrees, is the hypotenuse. This is the hypotenuse side. So you know that you use the hypotenuse side, and you look at this side. What is the relationship between theta and this side? Theta is opposite 7, so you know that you use opposite over hypotenuse, and that is sine, right? That is sine. So you use sine. So in this case, you're going to one sine. You want theta, so you're going to say sine theta equal to what's opposite? Opposite is 7. Or this is 13. Sorry, I know that the hypotenuse side is the longest side, so it cannot be shorter than any other side in this triangle. So this is 7 over 13. So actually, this, in order to find the angle, what you do is you say, you shift, you press, use your calculator, guys. Press shift and press cos and press sine. You press shift, you press the chosen trigonometric ratio. If it's sine, it's sine. If it's cos, it's cos. If it's tan, it's tan. But in our case, it's sine. It's going to be an inverse of sine. It's going to be sine inverse like this. 7 over 13. This will give us an answer. Can you guys press the calculator for me and tell me the answer to this? And this is equal to 30, 31 degrees. So I hope you guys understand this. We would do more questions if time was on our side, but time is not on our side. So what I'm going to do is I'm going to give you guys homework. This is a homework. This is your homework. This is your homework, guys. As you can see, the statement is in each of the questions below, calculate either the missing angle or side stated. Give your answer in one decimal. Uh, we are going to do corrections of this work when we meet next. Uh, I hope this lecture, I'm sure most of you, all of you now know how to use trigonometric ratios to find the unknown sides and unknown angles. So we'll meet again on Tuesday because Monday we don't have a period. I will meet on Tuesday. Have a great day.